Before we actually start drawing ray diagrams, here are some guidelines or rules which we should follow while we are drawing the ray diagrams. Rule number one, draw a minimum of 2 rays. So if I take any ray diagram, I have shown here a complete ray diagram when the object is at 2f distance. So we have to show at least 2 rays. So you can see here ray number one goes like this, gets refracted through the lens and goes like this. Another ray passes through the optical center and goes straight undeviated. So likewise, you have to show at least 2 rays out of the 3 rays that we have talked about. Just to recap, the 3 rays that we have talked about are: 1, passing through focus; 2, passing parallel to principal axis. This ray that we have shown just now is parallel to the principal axis. And third is passing through the optical center. So this second, so we have shown one this and second this ray in this particular ray diagram. So likewise, you have to show at least 2 ray diagrams, preferably these two, one parallel to the principal axis and the other passing through the optical center. Yes, even this ray can be considered as a ray passing through the optical center. So in fact, in this diagram, I have shown 3 rays. So the principal axis can also be considered as a ray passing through the optical center. But over and above the principal axis, we should draw 2 rays. So that's rule number 1. Rule number 2 says don't miss showing the arrow mark on the ray. So likewise, I have shown over here arrow marks throughout the ray on both the sides of the lens. So this is very, very important to indicate that the direction in which the ray is traveling. If you don't show the arrow, then you don't know whether the ray is traveling in this direction or in the opposite direction. So very, very important to show the arrow marks throughout the ray. Always show both f and 2f on either side. So if this is the lens, you have to show the focus on either side. This is f, and then we have to show 2f and 2f. So both these are to be shown on the principal axis. Remember, in this case, in the cases that we are discussing, this 2f will actually be the center of curvature. But because we are taking convex lenses which are symmetric on both sides, therefore this turns out to be 2f. Actually, this is the center of curvature and we should show it as C. So important to show f on both sides and 2f on both sides. Technically, this is f1 and this is f2. Similarly, this will be 2f1 and 2f2, but it's okay if we show it as f and f on both sides. Show the optical center marked O. So always remember to show the optical center O. Lens can be shown as a line with a label. So here I have shown the shape of a convex lens, but it's okay if you draw this as a principal axis and you show the lens as simply a line and then label it and say this is convex lens. So basically these two curved lines will not be there. That is perfectly fine. So that is permitted. Incident ray to be shown up to the vertical line passing through the optical center. So if this is the incident ray coming from the object, this is the incident ray coming from the object, this has to be shown up to the vertical line passing through the optical center. This is the vertical line passing through the optical center. So show this line up to this point and then show the bending. In reality, if this is the lens, the bending of the light starts immediately over here and then it bends over here and bends further down over here and goes like this. But since we are considering very, very thin lenses, we ignore the refraction happening within the lens. Meaning that we ignore the refraction happening at both these points. We consider that as happening only once at this particular point. Actually, the refraction is happening at this point as well as this point. But for sake of simplicity, we say that the refraction is happening only at this particular point. So that's point number 6. 7th point, real rays are to be shown by an unbroken straight line, whereas apparent rays shown by a dotted line. So in this case, we have all real rays, so they have been shown by a straight line. If we take the example of an object placed between focus and optical center, then we will get rays which are not real rays, which are apparent rays. So I have shown them as dotted lines, as you can see over here. These are not actual rays. The actual rays start from the object, pass through the lens, and go straight. These two rays. This is ray number 1, this is ray number 2. They are passing through the lens. These two are the apparent rays, and therefore they have been shown by a dotted line. And we discussed this when we talked about the concave lens, that when a ray of light is parallel to the principal axis, it will get diverged like this, and then we show a dotted line over here up to the focus, because this is not an actual ray, this is an apparent ray. It appears to come from this particular focus. Show the object as AB and the image as A dash B dash. So the object is marked AB, A the top point and B the bottom point, and the image has to be A dash B dash. Remember to make sure that the corresponding point, if this is A, its corresponding point is A dash, and this is B and its corresponding point is B dash. So this is how we mark the object and the image. As far as the image is concerned, we are expected to know and present 4 details about the image. One is the location. That means where the image is formed. So in this case, I'll say that the image is formed at 2F in this case. In this case, we will say that the image is formed behind 2F. So location. Second, nature, real or virtual image. So in this case, the image is real. Real image is one which gets formed on the other side of the lens. If this is the side of the object, this side is the side of the object, the image is getting formed on the other side of the lens. So that would be a real image. Whereas in this case, the image is formed on the same side as the object. So this is a virtual image. So we have to identify the virtual image. Now another important thing to note over here is, if it's a real image, it is shown by a full unbroken line, whereas a virtual image is shown as a dotted line. So over here, this image is virtual, so is shown as a dotted line. Whereas in this case, the image was a real image, so shown by a full unbroken line. Orientation of the image, whether it is erect or inverted. So in this case, we see an inverted image, whereas in this case, we see an erect image. And then we should also mention the size of the image as compared to the object. So we could write that it is smaller than the object, or we sometimes use the word diminished. Diminished would mean smaller than the object. Sometimes we will say it is equal, that means equal to the size of the object, and enlarged, or we use the word magnified. So we have to mention whether the image formed is diminished, or is it equal, or is it magnified as compared to the object. So in this particular case that I have chosen, the size of the image is exactly equal to the size of the object, whereas in this case the image is larger than the object, so I'll say it is enlarged or magnified. So these are some of the rules that we should follow while we are drawing the ray diagrams. I will refer to these while actually drawing the ray diagrams in the next video. Thank you.